Hello all, and welcome to our last lesson of the week. We are going to be talking about evaluating square roots, so make sure that you are on the correct page of your guided notes, and we're going to get started. Now, the first thing we want to define is perfect squares. Perfect squares are numbers that have rational square roots. So we've got our square root symbol like this, and a perfect square is, again, a number with a rational square root. Now this just means one that you know. So an example of a perfect square would be 4, because you know that the square root of 4 is 2. This makes for a perfect square. 81 would be another perfect square, because the square root of 81 is 9. So you can think of perfect squares again as ones that you know. A not perfect square would be maybe something like the square root of 7. The square root of 7 is not one that you know, and that means that it is an irrational number. So irrational numbers are roots you can't calculate in your head. So the square root of 7 was the example I gave. Another irrational number that's famous is pi. So between these roots and pi, these are the most common irrational numbers, though there are plenty of others. So the first one, number 1, circle the numbers below that are rational. So again, rational means that it can be written as a fraction and that you can do the root in your head. Some of these we don't have to worry about because they don't have roots. Now, 4 over pi, yes, it's a fraction, but pi is irrational. So this whole thing is irrational. Root 6 over 4, this is the same as root 6 and root 4. So while this is rational, root 6 is not. And again, just like here, if one part is irrational, the whole thing is irrational. Now, root 6.4 looks promising because root 64 is a perfect square. But if we think about this the exact same way that we thought about the last one, 64 over 10 would be the fraction form of 6.4. And again, 64, root 64, rational, root 10, not. So this whole thing would not be rational. Now here, root 9 and root 4, these both work, so this would be a rational number. And lastly, 4, 4 would be absolutely rational. As a fraction, it would be over 1. So we only have 2 rationals here, root 9 over 4 and 4. Now we can talk about how to evaluate square roots. As we said, some of these square roots are ones that you've seen before. If you haven't seen these before, please come and review them with me on Zoom. So for example, here we have -2 times the square root of 49, because remember when things are just shoved next to each other, that's the same as multiplication. And when you have this square root going long over all the numbers, that's the same as putting parentheses around them saying these are all in a group together, a group called that square root. So 30 minus 14 would be root 16, and then -2 times root 49. These are both perfect squares. -2 root 49 is 7, because 7 squared is 49. And similarly, root 16 is 4. Again, if you're not sure, please ask. One thing that's important to note is you'll notice the order we did this. If I think about my order of operations, square roots come from the word square, meaning that these are the same place in our order of operations as exponents. So this is where you want to put the square roots when you're doing your order of operations. And from there we can do our multiplication and our addition. -14 plus 4 equals -10. You can have two square roots multiplied together. Here we have root 25 is 5 times root 4, which is 2, which equals positive 10. And for part C, again, we have a nice group. We can add those together, and we end up with root 25 plus 7 is equal to 5 plus 7, which is 12. So, square roots, remember, if there's multiple things inside them, treat them like your parentheses, and then you will do them next because they are similar to exponents. Now, one thing that's also important is finding the square root of numbers. So when I'm asked to find a square root of numbers, a lot of you will probably jump immediately to saying this. Find the square root of 64. Oh, well, that's root 64, that's 8. They're not quite the same. The square root of the 64 is the thing that when squared multiplies to 64. Now, absolutely 8 is one of the answers, but there's another answer. Think to yourself for a moment, what else multiplies to positive 64 when squared? It's plus or minus 8. So the square root of 64 can be a positive or a negative. If you want to test that, negative 8 times negative 8. And so that's the way you would write it, is plus or minus 8 like this. Or you could write it as 8 and negative 8 with commas. And this is really helpful because it helps us to avoid coming into some other issues. If I asked for the square root of negative 64, this does not exist. It's like dividing by 0. It does not exist because you can't multiply a number by itself and get a negative. So you can't have the root of a negative number. Now here, we're looking at a fraction. We know that fractions are fine. We had a fraction right up here at the top, root 9 over 4. But here it's saying, oh, well, I've got 24 over 54. Those aren't perfect squares. That's all right, because hopefully you would notice they are both simplifiable. They both are divisible, in this case, by 6. So the real question is, what squared is equal to 4 over 9? Well, again, we're going to have plus or minus, because we have positive. The square root of 4 in the numerator is 2, and the square root of 9 in the denominator is 3. So plus or minus 2/3. This is also helpful if we look at D with negative 60 over negative 15. You might panic and think, oh no, there's a bunch of negatives. We can't do that. Well, a negative divided by a negative is a positive, and then these are both divisible by 15. You could also do this in 2 steps, dividing them by 5 and then 3. That would also work, and we end up with x squared is equal to 4 for the square root problem, meaning that the square root would be plus or minus 2. Again, if you have any questions, please put them in the private comments or come and ask me on Zoom. I'll talk to you later.